go for page 2 of your review for your upcoming test on 2D geometry and measurement. Problem number 4 asks you to draw examples of different angle relationships. The first one asks for adjacent angles. There's different ways you could do this. I'm going to just draw a couple of angles that share a common ray. They both share this ray. And so if I make little arc marks for the angles, this angle is adjacent to this angle. You also could make a shape, like I'll make a pentagon, and then this angle and this angle would be adjacent because they share this line segment. Vertical angles are formed by intersecting lines. So if you just draw some intersecting lines, you can mark a pair of vertical angles. So I'll choose these two. Vertical angles are opposite each other and they're congruent. There's another pair of vertical angles. Anytime you have intersecting lines, you have two pairs of vertical angles. This is the other pair. Complementary angles are two angles with a sum of 90 degrees. They don't have to be adjacent, so I'll just draw a 40-degree angle here and a 50-degree angle here. And since they add up to 90, they're complementary angles. If you show them adjacent to each other, you could just start by making a right angle and then make the other ray anywhere inside of that right angle, because then these will be your complementary angles. Supplementary angles have a sum of 180. Two angles with a sum of 180, you can draw those by drawing a straight line and then just drawing a ray coming off of that line, because then this angle is supplementary to this angle. You've seen examples of that in some of the problems earlier on the exam. A reflex angle is an angle that's greater than 180 degrees but less than 360 degrees. So you can draw any angle you want, but then you need to show the arc mark to. It's hard for me to draw that. You need to indicate, let me get a different color. You need to indicate this arc mark that shows people that you're talking about this angle rather than this. This looks like it might even be a right angle or obtuse angle. So there's a reflex angle. Acute angle is less than 90. So any just small angle would be acute, like that. Problem number 5. What name could you give to all of the numbers below? Order them from least to greatest. What you need to recognize here is that all of these decimal numbers, because of the bar notation, these are repeating decimals. Just like this one, negative 1.333, and the 3's go on forever. And any repeating decimal could be represented as a fraction. You don't need to know what fraction it is in order to solve this problem, but this one would be 5/9. This one would be negative 1 1/3. As long as you know that the repeating decimals can be represented as fractions, and you know that any number that can be represented in fraction form as a ratio of two integers, is a rational number. That's the name you could give to all of these. Even the 0 could be represented as a fraction, because you could say 0 divided by anything. I could say 0 divided by 11. The ratio of 0 to 11 is 0. So then to order them from least to greatest, we have to think about, probably better to put them into a standard form, decimal form, because this negative 13/10 is just negative 1.3, because 10/10 is 1 whole and 3/10 is 3/10. The 11/21 might require us to do a little division. 11 divided by 21, just because it's a little more than half, and so I don't know if it's. I suspect it's less than this first one, but I don't know for sure. So let's just do some division. How many 21s are in 1? 0. How many 21s are in 11? 0. Then I reveal the 0 in the tens place. I line up a decimal in my quotient. How many 21s are in 110? 5, because 5 21s is 105. The difference here is 5. And then I reveal the 0 in the hundredths place and bring it down. How many 21s are in 50? 2. 2 21s is 42. And now I have enough information to confirm what I suspected, that this is less than 0.555, repeating. So I almost said that's our least value, but certainly not, right? We have 0 and we have some negative values. The one, if I was going to make a number line and put 0 here as a reference, or our origin as a reference, as I went to the left into the negatives, the first negative I would run into would be this negative 13/10. And then this one, negative 1.3 repeating, would be a little bit to the left of that, because we have these 3's that go on forever. So the least value is this negative 1.3 repeating, followed by negative 13/10, followed by 0. And then as I move into the positive numbers, as we said, this is approximately approximately 52 hundredths, a little more than that, but in any case, we would definitely see 11 21sts before we would see 0.5 repeating. So 11 21sts is next, and then our greatest value is 0.5 repeating. So there's the list, and these are all rational numbers. Problem 6, in the figure, all angles are right angles, and all distances are in meters. What is the area of the figure? This is a composite area problem, a little bit trickier than some of the ones we've done, because there are some missing measurements that you have to calculate. There's so many different ways to do this one. I'm going to show you a couple different ways, and I'll show you what I think is the most efficient way. You could extend this side up to here, and extend this side down to here, and break this up into 3 rectangles, A, B, C. You see you have 8 by 9 here. That's straightforward. Here you would have to do some work to try to figure out how long this side is. And the 2 refers to this side. I know that this side of this rectangle from here to here is 11, because I can see the 3 and the 8. But this side, to be perfectly honest with you, I'm not immediately, oh, there's 10 here and 9 here, so this must be 1. So this one would be 8 by 1, this one would be a 9 by 8, and then this is 4, so that's clear. We don't have this measurement. We know this is 2, and we said before this whole thing's 11, so this must be 9, so 4 by 9. If you add up all those areas, you'll get the total area. But it's not the way I want to do this. I think there's a better way. And that's just one of the ways. You could certainly sort of like complete this rectangle, and then complete this other rectangle. Oops, if I could use my technology better. You could complete this 8 by 10 rectangle, and then you could complete this, get a different color, this rectangle by like this, and this one would be a 9 by 5, I believe. And then you could subtract this area, which I think you can find because you know this is 2, so this must be 6. And you know this is 10, and this must be 1. So if you do 80 and 45 is 125 minus 6. It's 119. That is the correct answer. Okay, but I'm going to show you the way I think is the best way. That's not clearly. Just remember 119. So we're going to compare that to what we get here in a minute. I think the best way to do this one is to complete the whole big rectangle. In other words, if I completed this whole rectangle all the way down to here and here, so this whole rectangle is this is 10 and this is 4, so I have 14 for this base. The 14 goes all the way from here to here. And then this height, I see I have 8 here and 3 here, so that's going to be 11 this way. So I have 14 times 11, or 154. Then I'm going to subtract out these pieces since they're not part of the figure. And these are easy to calculate because this is a 9 by 3 and this is a 2 by 4. So 154 minus 9 times 3 plus 2 times 4 is 154 minus 27 and 8. 154 minus 35 is, if I just subtract 34, that's 120. I subtract one more, that's 119. That's what we got when we use the other method also. And since the side lengths are measured in meters, this would be meters squared. We talked about 3 different ways to do this. I think there's probably, this program has a mind of its own when I'm trying to make a shape. I'm going to need to find a better program. I'm thinking, yep, it's still going. Okay. I think there are probably, I mean, we looked at 3 ways really quickly. There's probably many. I wouldn't be surprised if there were a dozen or more different ways to find this total area. But in any case, whichever one you use, if you're careful with your dimensions and if you're careful finding the missing dimensions you need, you should get 119 meters squared. That concludes the video for page 2. We'll pick up the review with page 3 on the next video.